Welcome dear students. In this lecture we are going to talk about the nitration of the benzene, which is an example of the electrophilic substitution reaction. The nitration can be defined as the introduction of nitro group which is NO2 to benzene, that is called as the nitration of the benzene. Now my dear students, for nitration of the benzene we use mixture of concentrated HNO3 and concentrated H2SO4 in 1:1. 1:1 means the equal quantity of the concentrated HNO3 and concentrated H2SO4 is mixed. And my dear students, this mixture that is called as the nitrating mixture. And the reaction, it takes place at 60 degree Celsius. Now my dear students, how this reaction takes place? This one is benzene. Nitric acid can also be written as this OH and NO2. It will become HNO3 in the presence of concentrated H2SO4 and 60 degrees Celsius. My dear students, every corner of the benzene has one carbon and one hydrogen atom. So hydrogen atom present at one corner of the benzene, that will join with OH, it will form water, and this NO2 group will be introduced to the benzene ring, and my dear students, we will get nitro benzene. Now let us talk about the mechanism of this reaction. The mechanism will follow same steps as we have already discussed in the general mechanism of the electrophilic substitution reactions of the benzene. Now in mechanism, the first step will be generation of strong electrophile. As you know, that benzene is highly stable because of its delocalized pi electrons. So the weak electrophile, it cannot penetrate the protecting sheath of the pi electrons. So that is why stronger electrophile will be required. And to produce the strong electrophile, the reagent and catalyst, they react together. Reagent is concentrated HNO3. Catalyst is concentrated H2SO4, and my dear students, you will get H3O positive plus NO2 positive plus HSO4 negative. Now in this case, dear students, this NO2 positive, it is called as nitronium, and this nitronium will act as a strong electrophile, and this HSO4 negative, that will act as a Bronsted base. As you know that the Bronsted base is the proton acceptor, and this HSO4 negative is actually the conjugate base of the sulfuric acid. So in this first step, the strong electrophile is generated. The second step will be attack of this strong electrophile on benzene. My dear students, now the strong electrophile, which is the nitronium that will attack the benzene, and a secondary carbocation is generated. This one is the carbonium ion, or you may say carbocation. And as the carbon, positively charged carbon, that is directly attached to two carbon atoms, so it will be an example of 2-degree or secondary carbocation. My dear students, in the third and final step, there will be regeneration of catalyst. As you know that catalyst is a substance which increases the rate of reaction, but it is never used in the reaction. And during the electrophilic substitution reactions of benzene, the role of the catalyst is to help in the production of the stronger electrophile. So in the last step, now the Bronsted base which was produced in the first step, it will take, or it will accept this hydrogen, and the bond which is present between carbon and hydrogen, that will be shifted inside the ring between two carbon atoms. In this way, H2SO4, which was the catalyst, that is regenerated, and you will get nitrobenzene, which is your main product. So this nitration is very important with examination point of view, as the MCQs can be asked from this, that what is meant by the nitrating mixture, what should be the ratio between the concentrated HNO3 and concentrated H2SO4. Then this point is important for MCQs, that the temperature should be 60 degrees Celsius. And my dear students, the stronger electrophile, it can be asked in the MCQs, and that is the nitronium ion. And then a very important point, the Bronsted base is HSO4 negative, and you should keep in mind that the same Bronsted base is produced in both nitration and sulfonation reactions of the benzene. In the sulfonation, HSO4 negative is produced. What kind of carbonium ion is produced? So that is the secondary carbonium ion. So these are the some important points related to the multiple choice questions. Even the mechanism can be asked in the short questions, and nitration of the benzene as electrophilic substitution reaction, that can be the part of the long questions. So this nitration of the benzene, that is a really very important topic as far as the annual exams are concerned. So this was all about the nitration. I hope so the lecture will be understandable for you people. In case you find any problem, you can ask in the comment section. I will definitely answer. Till then, take care.